Good evening and welcome to my channel. Today we'll be looking at design of solar power system. Taking you through this lecture is Engineer Binoba Charles, lecturer, Federal University of Petroleum Resources, Efru, Delta State. What is solar power system? Solar power system is a collection of components that convert sunlight into electricity. A solar power system consists of a solar panel which capture the sunlight and convert it into direct current, consists of an inverter which converts the direct current produced from the solar panel into alternating current that can be used by appliances and also be fed to the national grid. It also consists of a charge controller which regulates the charging voltage and current to the battery, and it also consists of a battery for energy storage which can then be used at later time, such as night hour or during period of power outage. And it also consists of mounting hardware which include the cablings, the solar panel hangers, and also the cablings, breakers. In this lecture we are going to be looking at how to design a solar power system. For example, if a room is to be powered by solar and the room has the following appliances: two ceiling fans rated 100 watts each, 6 bulbs rated 60 watts each, and 2 television sets rated 120 watts each. So if the loads are to be used for 6 hours per day and the available sunshine hour per day is 5 hours, and assuming the panel and batteries available in the store are rated 12 volts 200 watts and 12 volts 150 amp hour, calculate the actual load, the total load assuming inverter loss of 25%, the inverter rating in volt ampere using a power factor of 0.8, the battery capacity using a factor for reserve of 75%, the number of battery for backup hours, how will the batteries be connected, the battery charging current, battery charging time assuming a charging loss of 40%. Number 9, wattage of the panel array, number of panels, and the ampere of the charge controller if the panel will be used for charging battery only. Scenario 1. Then scenario 2, which is number 10, wattage of panel array, number of panels, and ampere of the charge controller if the panel will be used for charging the battery and powering the load at the same time. Then number 11, how will the panels be connected? So we are going to look at question 1 to 11 and we are going to see how to approach these questions. So we take question number 1, calculate the actual load. For us to calculate the actual load, we go back to the question. We notice that we have 2 ceiling fans, each of them rated 100 watts. So all we need to do is to multiply 2 times 100. We are going to have a wattage of 200 watts. Then we have 6 bulb rated 60 watts each. So multiply 6 times 60, we are going to have 360 watts. Then we'll have two television set rated 120 watts each. So we say 2 times 120, we're going to have 240 watts. So we're going to add all these wattage together in order for us to get our total load. So this is 120 times 2, we'll have 240, plus 60 times 6, which is 360, plus 100 times 2, which is 200. So by the time we add 240 plus 360 plus 200, we're going to have 800 watts. So that is our actual load. The next thing we are going to calculate is the total load, assuming an inverter loss of 25%. There are two types of inverter loss. Inverter loss as a result of conduction and inverter loss as a result of switching. Inverter loss as a result of conduction are produced when the switch is in the on state. So when the system is working, that is, those losses produced by the inverter are referred to as conduction loss. While switching loss are produced when the switch is turned on and turned off. So by the time you are turning on your switch, there's a loss that occur. By the time you are turning off your switch, there's a loss that occur. This loss is referred to as switching loss. There is a standard for calculating inverter loss. It is usually between 20 to 30%. But for the purpose of this example, we are going to use 25% in order to calculate our inverter loss. So we see that our total load is equals to actual load plus inverter loss. Total load is equals to actual load plus inverter loss. So first, we are going to calculate our inverter loss. Inverter loss is equals to 25% of our actual load. So our actual load is equals to 800 watts, which is this. When we take 25% of it, we are going to have 200 watts. Then our total load will now be equals to our actual load, which is 800 watts, plus our inverter loss, which is 200 watts. We're now going to have a total load of 1000 watts. The next question we are going to calculate is the inverter rating in volt ampere using a power factor of 0.8. So inverter rating in volt ampere is equals to your total load in watts divided by your power factor. Total load in watts divided by your power factor. So our total load again, if we go back, see that our total load is equals to 1000. So extract it, put it here, we have 1000 divided by our power factor given to us as 0.8. So your power factor can be between 0.7 to 0.9. So for the between 0.8 to 0.9. So for this question, we are given 0.8. So we use that particular figure to divide your total load. And by the time we do that, our inverter rating in volt ampere is equals to 1250 volt ampere. The next one to calculate is question 4. They say battery capacity using a factor for reserve of 75%. So battery capacity is equals to 2 times total load in watts times backup hours times factor for reserve all over battery voltage. When we say factor of reserve, what we mean is that the amount of energy you want the battery to retain when you are using it. Batteries are not usually discharged to 0%. If you want your battery to last longer, it is advised to always use a smaller part of the voltage while you are reserving a larger part. So that is why the factor of reserve is always considered when calculating your battery capacity. So depending on the figure you want to use, they are usually between 70% to um 70% to 80%. So depending on the value you want to use, you can use that as your factor of reserve in order to sustain your battery life. So according to the question, our backup hour equals to 6 hours. That is the number of hours you want to be losing the load per day. So your battery voltage, if you go back to your question again, your battery available are rated 12 volts, 150 amps. So your battery voltage is 12 volts. So by the time we input all those two times total load 1000 times your backup hour 6 hours times your factor of reserve 0.75 divided by battery voltage, which is 12 volts, we now have our battery capacity to be 750 amp hour. The next question is the number of battery for backup hours. So how many batteries do we need for this backup hour? To calculate that, the number of batteries simply equals to calculated battery capacity all over the battery capacity of the battery available. So the capacity of the battery available according to the question is 12 volts, 150 amp hour. So by the time we take the calculated battery capacity, which we calculated as 750, and we divide it by the available capacity, which is 150 amp hour, the result is going to give us 5 batteries. So the number of batteries we need to achieve that particular result, they are 5 batteries. Then we'll go to the next question. How will these batteries be connected? How will these batteries be connected? The batteries will be connected in parallel to attain the required amp hour. So we need to actually connect this battery in parallel so that we'll be able to achieve our amp hour. Because when batteries are connected in parallel and they're having the same voltage and same ampere hour, all we need to do is to take the voltage of one of the battery, then we add up all the amp hour together. So that is why this system, for us to achieve our required amp hour, it is clear that we must connect the battery in parallel. Again, because of the system requirement, the inverter is rated 12 volts. That is another reason why we must also connect it in parallel, because if we connect those batteries, those 5 battery in series, we are going to have a total voltage of 60 volts to the input of the inverter, and that will definitely damage our system. So and the amp hour of the battery will be 150 amp hour at 60 volts. That will not be able to drive our load for the required time. So in order for us to get it right, we need to connect the batteries in parallel in order for us to have a system that will give us 12 volts, a battery combination that will give us 12 volts and 750 amp hour. The next one to calculate is our battery capacity. Battery charging current. Battery charging current. The battery charging current is equals to calculated battery capacity over 10. So our calculated battery capacity again is 750 amp hours. So we divide it by 10. We are going to have 75 amps as our battery charging current. So the next question number 8, is the battery charging time assuming a charging loss of 40%. Usually when battery are being charged, there are some losses that happen, and these losses, they are usually as a result of the cablings that are used for the system and also some other factors. So it's very important that we consider these losses when trying to calculate the battery charging time. So battery charging time is equals to calculated battery capacity plus 40% of the calculated battery capacity divided by the charging current. The charging current we just calculated here as 75 amps. So all we need to do, the capacity of the battery is equals to 750 amp hour plus 40% of that again divided by 75 amps. So by the time we say 750 plus 300, we have 1050 amp hour divided by 75 amps. So that will give us a charging time of 14 hours. 14 hours. The question number 9. What wattage of panel array, number of panels, and ampere of charge controller if the panels will be used for charging battery only? So for this particular question, the panels are strictly used to charge the battery. So what it simply means is that during the period of charging the battery, the system is not used for any other purpose but strictly for charging the battery. It is after charging the battery during the day, that is only when the energy stored in the battery will be used. So that's exactly what this particular question implies. And to do that, the wattage of panel array is equal to calculated battery capacity times solar panel voltage divided by sunshine hour. According to our question again, our sunshine hour is equals to 5 hours per day. So this simply means that the number of hours you can have the sunlight available to use is 5 hours. It varies from location to location. In some location you can have up to 6 hours sunshine hour per day. In some location you can have 4, so depending on your location. But for this particular question, we are taking 5 hours per day. So if we take that, so we just say 750 amp hour, which is the battery capacity, times the solar panel voltage according to the question, which is 12 volts. Then we now divide by the sunshine hour, which is 5 hours. We are going to have our wattage of our solar panel array as 1800 watts. The next one to calculate again is the number of panels required. Number of panels required. Number of panels required is simply the calculated wattage of solar panel array divided by the available wattage of solar panel supply. So again, from the question, the available wattage of the solar panel supply is 200 watts. So all we need to do, the value we got, just take it and divide it by 200 watts. We see that the total number of panels that are required for this particular installation for charging the battery alone is 9 panels. And the ampere of the charge controller required, which is the next question. So the ampere of the charge controller required is simply the calculated wattage of the solar panel array divided by the solar panel voltage. So what we calculate here, 1800 watts at the solar panel array, we just divide it by the panel voltage from the question again, which is 12 volts. 200 watts. So this is the panel voltage. So we take the wattage of the calculated solar panel array divided by the solar panel voltage. Then we have the ampere of the charge controller as 150 amps. So if you are going to install this system, the minimum ampere rating of the charge controller you can buy should be a little above 150 amps, because you need to consider some losses, and in case there are any form of expansion, the charge controller will be able to tolerate it. And the charge controller input voltage must be 12 volt. So we go to question 10. They say the wattage of panel array, number of panels, and the ampere of the charge controller if the panel will be used for charging the battery and powering the load at the same time. So this is case 2. In this case, as you are charging the battery during the day, you are also using energy from the solar panel to also power your load. So if you use that 9 number of solar panel to do this particular question, you will not charge your battery effectively. So in order to handle a situation whereby you will still be charging your battery and also be using your load, what you need to do in this case, you will take the wattage of your solar panel you calculated, which is 1800 watts, and you are going to take the calculated load, your calculated load from example 2, your total load you calculated from the question 2, which is 1000 watts. You are going to take it and add it to your calculated wattage of your solar panel you just calculated when you assume that you are using it to charge the battery alone. So by the time you add this wattage to this, you have a total wattage of 2800 watts. Then question B say the number of panels required. So again, the number of panels required in this case is calculated by the calculated wattage of solar panel area that you just calculated just now, divided by the available wattage of the solar panel, which is 200 watts. So you can see that in case 2 now, the total number of panels you need is 14 panels. So when you do your installation, while the other 9 panels are charging the battery, the other 5 panels will be used to supply the load at the same time, so that the battery can be properly charged for the number of sunshine hours that will be available. Then the last question, which is the capacity, the ampere of the charge controller required, is the same thing. So you calculated wattage of solar panel array that you just calculated just now, divided by your solar panel voltage, which is 12 volts. By the time you do that, you have your ampere of your charge controller required as 230 amps. 230 amps. So that is the result you get for your ampere of your charge controller. Then the last question is, how will this panel be connected? So again, since the batteries were connected in parallel, also the panels will also be connected in parallel in order for you to have your 12 volt system, because if they are connected in series, your voltage you are going to get from the output of the panel will be higher than the battery voltage and also higher than inverter input voltage, and that will damage your system and will cause an effect to the battery. So it is advisable that for this particular scenario, you connect your solar panels in parallel. So I want you to try this question, try it and leave your answer in the comment section. The question reads, if a room is to be powered by solar and the room has the following appliances: 3 ceiling fans rated 100 watts each, 10 bulbs rated 60 watts each, and 4 television sets rated 120 watts each. They say if these loads are to be used for 6 hours per day and the available sunshine hour per day is 5 hours, and assuming the panel and batteries are available in the store are rated 12 volts, 200 watts, and 12 volts, 150 amp hour, you have to calculate the actual load, the total load assuming inverter loss of 25%, the inverter rating in volt ampere using a power factor of 0.8, the battery capacity using a factor of reserve of 75%, the number of batteries for backup hours, how will the batteries be connected? Number 7, battery charging current. Number 8, battery charging time assuming a charging loss of 40%. Then number 9, wattage of panel array, number of panels and ampere of charge controller if the panels will be used for charging battery only. Then number 10, wattage of panel array, number of panels and ampere of charge controller if the panels will be used for charging battery and powering load at the same time. Then number 11, how will the panels be connected? So you can leave your answer in the comment section. If you find this video very interesting, I want you to like this video and also share this video with your friends and colleagues. Thanks for watching.